we're going to be talking about multiplying rational expressions. And whenever you're multiplying a rational expression, this process follows along exactly like what multiplying any two fractions would be. So remember, if you're multiplying fractions, what you should be doing is you should reduce first, and then you're going to multiply straight across. So the reason why we reduce first is this actually is a simpler process than multiplying first and then reducing at the end. If you multiply first, then you're making your life harder than it needs to be, because you'll just have bigger factors to contend with. So, for example, this is going to be something like 9/10 times 5/6. Rather than say, okay, this is going to end up being 45/60, what we should be doing is we should be saying, oh, well, I see 5 goes into both 5 and 10. 5 goes into 5 once, it goes into 10 two times. And then I look and see that 3 is a factor of 9 and 6. 3 goes into 9 3 times. 3 goes into 6 2 times. So when I multiply, I'll have 3 times 1 is 3, 2 times 2, 4. And we'd be done. When we're multiplying, it's a good policy to reduce first and then multiply straight across. So the same process happens with rational expressions. Say we've got something like x minus 1 times x plus 5 over x plus 7 times x minus 3. And let's multiply this by x minus 3 over x plus 5. And I'll also have also put an x plus a 2 down here. Now, I could just multiply straight across, and that could get very messy very quickly. Instead, I'm going to look for whatever I have in common first. I see an x plus 5 here, anything on top, so x plus 5 and an x plus 5 on the bottom. I also have this x minus 3 on the top and an x minus 3 on the bottom. So all I'm left with, my only remaining factor here on the top, is that x minus 1. My only remaining factors in the denominator are that x plus 7, that's a 7, and x plus 2. Now if I want to, I could go ahead and FOIL this out, but honestly, it's okay to leave things in factored form. Now, in this example, everything that we started with was already factored. We're not always going to have that particular benefit. Sometimes we might have some other work to do before we do this. So what we're going to end up doing, ultimately, our new process is going to be this. We're going to fully factor our polynomials. We're going to then reduce our like factors top to bottom. And then, last but not least, we're going to multiply. So here's what this is going to look like. So we've got something like 3x squared minus 9x. And I'll have this over x squared minus 6x plus 5. And this is going to be equal to, oh, not equal to, let's multiply this by x squared minus 25 over 2x squared minus 6x. Oh, that looks messy, doesn't it? So instead, we need to start factoring this stuff. And I'm going to go ahead and I'm going to take a couple extra steps just to show you where all of these things are coming from. So this is all of this. And let's think about where this, like 3x squared minus 9x, I can factor this, and the factoring that we're going to use is just greatest common factor. So what I can pull out of both of these is a 3x. And I'll have x minus 3. So I've got 3x times x minus 3 here. Okay, now we've got our, just keep this as our little thought bubbles over here. And so this can be an internal process, or you might need some scratch work to do it. That's fine. X squared minus 6x plus 5. Well, this is a simple trinomial. Looks like my key number here is 5, and looks like both of our numbers are going to be negative, so -1 and -5. Okay, so this is going to end up being x minus 1 and x minus 5. Okay, x squared minus 25. So with our x squared minus 25, this is the difference of squares. So this is just going to be x plus 5 times x minus 5. So x plus 5 times x minus 5. Last thing here is another greatest common factor. Or 2x squared minus 6x. It looks like I can pull a 2x out of both of these. And I'll have x minus 2x times x minus 3. So I've got 2x times x minus 3. And now comes the fun part. We get to reduce any like factors. Now, a couple of these are going to be really obvious. I see x minus 3 and x minus 3 right there. I also see x minus 5 and x minus 5 right there. So those are fairly self-evident. Something that might take us a moment to spot is I've also got an x right there. X over x is still, x divided by x is still 1. So that is also a common factor. So what I've got left here is I've got a 3. And my x plus 5 up top. Down below I have this 2. And x minus 1 down below. And that right there is going to be our answer. Okay, so let's move on to, let's do another example. And whenever you're doing multiplication, I think it's also important to bring up division because, and actually, yeah, why don't we do that? Let's do some things with division as well. Because when you're dividing two fractions, I always like to remind folks about division of fractions. Let's say I've got something like 4/5, and I'll divide that by, say, oh, I don't know, 2, 2/7. Whenever you're dividing with fractions, what you're going to do is, I always say KFC. Keep that first fraction, flip your second fraction, and change your division to multiplication. So KFC. Another way of saying this is Missy Elliott division. You're going to bring the thing down, flip it, and reverse it. And from here, of course, we're just going to go ahead and multiply as we normally would. I'm going to reduce my like terms, and then I'll multiply straight across. 2 times 7 is going to be 14 over 5. And we're done. So last thing that we should do here is let's show this with a rational expression. The same idea works. Keep that first, flip the second, change the division to multiplication. So with this, we can do something like, and I'm going to keep this fairly simple. Let's say we've got x squared minus 4 over x squared plus 2x minus 3. And I'm going to divide this by x plus 2 over x minus 1. So first things first, I'm going to keep this first fraction. I flip that second fraction. Oops, sorry, that's a minus 1. Don't know why I did that. And then I change that to multiplication. Well, from here, it's pretty straightforward. I'm going to go ahead and factor. Difference of squares, that's just going to be x plus 2 times x minus 2. Here, my key number would be a -3. I'd need a factor pair of -3 that adds up to be 2, and that looks to be like a -1 and a +3. So this would be x minus 1 times x plus 3. And I still have my x minus 1 here and my x plus 2 here. So now I get to reduce. X minus 1 cancels with x minus 1. X plus 2 cancels with x plus 2. So what I have left is just going to be this x minus 2 over x plus 3. And we're done.